Hi, I'm Daniel Hummer, and I'm going to talk about the second thing that I'm going to be presenting at AGU this year. This is work that I'm doing here at Carnegie with Bob Hazen, and I'm here in the SEM lab where we measure the chemical compositions of minerals to show you the project that I'm going to present on Friday at AGU, and that is a statistical analysis of how often elements occur together in minerals. So in other words, all of the elements on the periodic table here occur in a certain number of mineral species, and there's a total of 5,000 mineral species that we know about. And so we can go through each element and say, well, how many species contain silicon, and how many contain phosphorus, and how many contain sulfur, and so on. But what we can also do is go a step beyond that and analyze how often do certain pairs of elements go together in minerals. So we can look, for example, at how many minerals contain carbon and how many minerals contain oxygen, and from that we can estimate, well, how many just by chance should have both carbon and oxygen, and we can compare how many do contain carbon and oxygen together, and it turns out it's way more than we would expect by chance. So carbon and oxygen are very highly correlated with each other because we have lots of carbonate minerals like this calcite piece right now. This is CaCO3. So because there are so many minerals that have that CO3, most minerals that contain carbon also contain oxygen. And so we can do that across the entire periodic table for every pair of elements and figure out which pairs of elements love to go together in minerals and which pair of elements love to stay apart in minerals. So, and we see both. We see correlations and anti-correlations. So for example, we just said that oxygen and carbon love to go together in minerals, but it turns out oxygen and silver, all the way over here, do not like to stay together in minerals. Silver prefers sulfur instead of oxygen. So there's all kinds of relationships like this that we've discovered doing this statistical analysis, but the really exciting part is that we can do this analysis for all the minerals that we know of on Earth today, including ones that are produced by life, which it turns out is about 2/3 of mineral species, according to work that Bob has done. And we can compare that with how the picture looks for minerals that don't occur, that don't need life to occur. So we can compare an Earth planet with life and a planet like Earth but without life and look at how the chemical signatures, how these element pairs in minerals change between a life planet and a non-life planet, which could give us a clue as to how to look for planets with life out in the universe. So that's what I'm going to be presenting on Friday, and I hope you can join me, and thanks for watching.